This is Mrs. Appia with Lesson 6, Drawing Geometric Shapes. The essential question is, name 3 uses of a compass. For our exploratory challenge, you will need a few tools today. You will need a compass, which has a pencil in it. You will need a ruler with centimeter measurements, and you will need a protractor as well. Use a rule, protractor, and compass to complete the following problems. First, use your ruler to draw 3 segments of the following lengths: 4 centimeters, 7.2 centimeters, and 12.8 centimeters. Label each segment with its measurement. Let's get started with our segments. Recall that a centimeter is roughly the width of a pinky fingernail. And our first segment will be 4 centimeters long. So here's the 4, so I'm going to go from the starting line, 0, 1, 2, 3, 4, and that is a 4 centimeter segment. Next we want 7.2. Again, I'm going to go back to 0, 1, 2, 3, 4, 5, 6, 7, and each millimeter is 1/10 of a centimeter. So there's 7.1, 7.2. So we have a 7.2 centimeter segment. Finally, 12.8. Now this one will barely fit on your page. So you want to find the 12.8, make sure that it fits on your page, and then back it up. So here's 12, 12.5, 6, 7, 8, 12.8, and then I'm going to go back to 0. 12.8 centimeters. Next, draw complementary angles so that one angle is 35 degrees. Recall that complementary angles have a sum of 90 degrees. So if one of our angles is 35 degrees, then we can subtract to find the measurement of the second angle. So one measure will be 35 degrees, the second one will be 55 degrees. Are the angles required to be adjacent? Recall that adjacent means that they will share a vertex and a ray. So one of the angles would be 35 degrees, and then the other angle would be 55 degrees, and together they have a sum of 90 degrees. They are not required to be adjacent. They could be separate angles with their own vertex and rays, or they could be together like this. So for simplicity, I'm going to draw mine with them being adjacent. It's just a shorter, easier construction. That's going to be the bottom segment. Now I want to mark off and measure the 35 degrees. So make a mark on your segment and then line up this mark on your protractor with the mark on your segment. Also, you want to level off the protractor with the segment that you have drawn to accurately measure your angle. Follow the segment to 0, 10, 20, 30, and then halfway between 30 and 40 is 35 right here. So that will be the 35 degree mark. Then you can take a straight edge to connect your dots and draw your ray. And that is the 35 degree angle. Notice that it is an acute angle. Next I can mark my 90 degree angle. I'm going to line this back up, making sure that my protractor is level. And then from the segment 0 to 90, here's the 90 degrees. So that's going to mark the second angle, which is going to be 55 degrees. And I can see that it's 55 degrees. We'll measure that in just a moment, just to prove it. So I'm just double checking to make sure that this is 55 degrees. Lining that up, leveling the protractor, and there halfway between 50 and 60 degrees is my 55 degree angle. Again, complementary angles are 2 angles that have a sum of 90 degrees. Next, Next, draw vertical angles so that one angle is 125 degrees. Recall that vertical angles are angles formed by two intersecting lines, so it might look something like this. And this is the 125 degree angle formed by the intersecting lines. Recall that vertical angles are opposite each other and equal in measure, so this one will also be 125 degrees. And then it says label each angle formed, so then we'll have to find out what is the measure of this angle as well. Let's begin our construction by drawing a line. I'm going to mark where the intersection will be, and then I need to mark this angle correctly so that it is 125 degrees. So I'm going to line up my mark with the mark on the protractor. I'm going to level off the protractor with the segment that I've drawn, and then I'm going to measure 125 degrees. From here I go to 0, 10, 20, 30, all the way 120, and then 125 would be halfway between 120 and 130. So I'm going to mark that off, and this will give me a 125 degree angle. And that is the obtuse angle, 125 degrees. The opposite angle is also 125 degrees. Then, to measure this angle, there are two ways that I could do it. I could measure it with my protractor, or I can use the fact that these two angles are supplementary and subtract from 180. So measuring, here we have from our segment 0, 50, 55 degrees. So this is a 55 degree angle, and I can verify that that's correct. These two angles are supplementary and should have a sum of 180 degrees. So 125 plus 55 is 180 degrees. Draw three distinct segments of length 2 centimeters, 4 centimeters, and 6 centimeters. Use your compass to draw 3 circles, each with the radius of one of the drawn segments. Label each radius with its measurement. Before we draw the circles, let's go over on a piece of scratch paper how to use a compass. Here's our compass. You want to keep your pencil tip about the same length as the tip of the compass. When you open and close your compass, you are determining the size of the radius of your circle. This one has measuring in inches, so if you put it at 1, this would give you a radius of 1 inch for the circle. So what that would look like, then you would not need a ruler to measure that 1. You would just mark your compass at 1, put your tip here, and then I'm going to rotate my paper, putting pressure on the tip of the compass, not the tip of the pencil, and that's going to draw your circle. A couple of things about using your compass. The distance from the pencil tip to the tip of the compass determines the size of your radius. If you want a smaller circle, you want a smaller radius, then you move the pencil in. If you want a larger circle, that means you want a larger radius, so you move your pencil size out, and that's going to give you a larger circle. When you make your circle, it helps to draw your circle accurately if you keep your compass on a bit of an angle instead of straight up and down. Also, you could turn your compass around like this. When I do it that way, sometimes my pencil, my tip will move and it won't be entirely accurate. So that's a little more difficult for me. For me, the best way is to put my tip of the compass down, put the weight on this tip, keep this at a bit of an angle toward the paper, and then I rotate my paper in a counterclockwise fashion, and that gives me a pretty good circle. Alright, let's get back to our constructions. We're on page 39. The three distinct segments. I'll start with the 2 centimeters. That's going to be the radius for my first circle. Then I want 4 centimeters, so I'm just going to move over and make 4 centimeters. And I need 6 centimeters, so I'm going to go back over here and 6 centimeters. I'm going to label those 6 centimeters, 4 centimeters, and 2 centimeters. And then I'm going to draw my circles. So I'm going to take my compass and I'm going to put the tip on the center, put my pencil on the other length, and remember that this is going to be the length of the radius, and I'm going to rotate my paper around. Okay, so there's my 2 centimeters. Then I'm going to put my pencil tip on the center of the circle and the pencil tip on the end of the segment. This is the radius of my 4 centimeter circle. I want to keep the weight on this tip and just rotate my paper around. And finally my 6 centimeter circle. You put your pencil tip on the radius and the tip of the compass, the pencil tip on the other end, and then rotate your paper around. And it does take some practice, so if it's not perfect the first time, that's quite alright, just keep practicing. Next, draw 3 adjacent angles, B, C, so that A equals 25, A equals 90, and A equals 50. Label each angle with its measurement. That doesn't quite make sense with the way that they've written it. I believe that there's been a typo. I believe that they want angle A to equal 25 degrees, angle B to equal 90 degrees, and angle C to equal 50 degrees. Recall that adjacent means that they will share a vertex and a ray, so it will look something like this, where this is angle A, this is angle B, and this is angle C. So I'm going to get started. I'm going to just draw a segment down here. That will be the ray for the first angle. I'm going to mark where my vertex is going to be. I'm going to measure off a 25-degree angle, line up your point, level this with the segment you've drawn. Follow it to the end of the segment to 0, 10, 20, 21, 22, 23, 24. 25 is right here. I'm going to go ahead and connect that using the straight edge of my protractor, and that's my 25-degree angle. Next I want 90 degrees. Now this is the ray that they're going to share and the vertex, so I'm going to line up the vertex with the point on the protractor and level off my protractor. Then from 0 all the way over to 90. That's the 90-degree angle. And finally, I want a 50-degree angle. I'm going to rotate my paper, put the vertex, line it up with the mark on my protractor, level off my protractor, follow it to the end of the segment where it is 0, and this one is going to be a 50-degree angle, 10, 20, 30, 40, 50. So here's my 50 right here. Take a straight edge, line it up, draw the ray, and label the angle, 50 degrees. So this is angle A, angle B, and angle C, 50 degrees. Next, draw a rectangle ABCD so that AB is equal to CD is equal to 8 centimeters. BC equals AD equals 3 centimeters. So let's see what that might look like. We know that it's going to be a rectangle so that the opposite sides are parallel, and the opposite sides are equal to each other. And it says a rectangle ABCD. So we have A, B, C, D. A, B, and C, D are 8 centimeters. A, B, and C, D are 8 centimeters each. And then B, C, and A, D are 3 centimeters each. So now I have an idea of what this will look like. I'm going to go ahead and start by making my first segment, and I know that this needs to be 8 centimeters long. So I'll take my ruler and measure off 8 centimeters. Next, I know that on a rectangle, these are going to have to be 90-degree angles. So I'm going to take my protractor and mark a 90-degree angle. Here is 90 degrees, and I'm going to do that on both ends, lining this up 90 degrees. Next, I'm going to draw my 90-degree line. Now, I know that this can only be 3 centimeters tall, so I'm going to go ahead and mark the 3 centimeters. And over here, I'm also going to measure out the 3 centimeters. Then just connecting these will give me the final segment. Alright, so this is point A, B, C, and D. And we know that all of these are 90-degree angles. Draw a segment AB that is 5 centimeters in length. Draw a second segment that is longer than AB and label 1 and point C. Use your compass to find a point on your second segment, which will be labeled D, so that CD is equal to AB. So first, let's get started with drawing a segment that is 5 centimeters long. And we want to label that AB. And we know that that's 5 centimeters. Next, draw a second segment that is longer than AB. Label one endpoint C. Use your compass to find a point on your second segment, which will be labeled D, so that CD is equal to AB. So this is one of the other uses for a compass, and that is to measure and mark off segments of equal length. So here I'm going to turn my compass over, and I'm going to put the tip on the end here at A, and then I'm going to measure this length. So that is the length of segment AB. Now, it says use your compass to find a point on the second segment, which will be labeled D, so that CD is equal to AB. So here is the length of AB, and we want to mark that off on here, and you're going to make an arc. And that shows that this segment AB is the same length as this segment CD. And we're going to label that point D. Next, draw a segment AB with the length of your choice. Use your compass to construct 2 circles. A circle with center A and a radius AB, a circle with center B and a radius BA. Describe the construction in a sentence. Well, let's think what this would look like before we actually construct it. The segment AB might look like this. Then a circle with center AB and radius AB. So if this is the center and this is the radius, then the circle would look like this. Then a circle with center B and a radius BA. So this is the center and this is the radius, then your circle would look like this. And that's what our drawing will look like. So we'll go ahead and draw segment AB, the length of your choice, and I think I will make it 3 centimeters. And this will be point A, and this will be point B. Then, first I'm going to use A as the center, and that's going to be my radius. So I'm going to turn my paper around. And then I'm going to use B as the center of my circle, with A as my radius. I do better turning my paper counterclockwise. And there's my construction. Next, draw a horizontal segment AB, some centimeters in length. I'm not sure exactly what that says there. Let's make that 10 centimeters in length. Alright, so then I'm going to label, let's see, draw a segment AB, 10 centimeters in length, AB, and that's 10 centimeters total. Label a point O on AB so that something is 4 centimeters from B. Alright, 4 centimeters from B. So here's B right here, and 4 centimeters away from that. And it says label point O, so that's going to be point O. And then this distance is 4 centimeters. Point O will be the vertex of angle COB. Okay, so angle COB. So that angle, it might look like this, or like this, angle COB, I'm not sure yet. Draw ray OC so that the ray is above AB and angle COB is equal to 30 degrees. Okay, so here, this would be 90 degrees, 80, 70, 60, 50, 40, and it says make it 30 degrees. So I need to use my compass and measure a 30-degree angle. And then it says it's above AB, so I know that it's not supposed to be down here. So then I'm going to take my protractor and measure the 30 degrees, putting this on O, following it to the end to 0, 10, 20, 30. There's my 30-degree mark. And I'm going to use my straight edge. I'm going to label this C, and then angle COB is 30 degrees. Draw point P on AB so that 4 centimeters from A. Alright, so from A I need to measure out 4 centimeters. From A, 4 centimeters would be right here. And it says call that point P. Label P so it will be the vertex of angle QPO. Angle QPO. So here's PO. So this angle is going to be somewhere here. This would be 90, 80, 70, 60, 50. Draw a ray PQ so that the ray is above AB. So it's going to be up here and not down here. And that's 30 degrees. So it's also going to be a 30-degree angle. So now I want to take my protractor and I want to line up the point on my segment with the point on the protractor. Level off your protractor, and I want it to be 30 degrees. Now, 30 degrees from here would look like this, and then 30 degrees from here would look like this. So then you think, well, which way is it supposed to go? We want QPO. So here's P and here's O. So it's going to be using this section. Okay, so if this is our mark, then we go from this side, 0, 10, 20, 30. Alright, and then this is going to be Q. So we have QPO right here is 30 degrees. Before we turn to page 40, I wanted to go back over this. It said to describe the construction in a sentence. So for this problem, notice that the two circles are the same size. One has center A and the other has center B, and both circles have the same radius, AB. Pause the video and copy that into your notes. Draw a segment AB of length 4 centimeters. Draw the same circle from A and from B. That is to say, do not adjust your compass in between, with a radius of a length that allows the two circles to intersect in two distinct locations. So let's just draw a sketch of what that might look like. If this is the segment AB, and then we want to draw two distinct circles that only intersect in 2 points but not one. So if we drew the circles like that, they do not quite intersect, so that would not work. If we drew them a little bit bigger, here they intersect at only 1 point. We want them to intersect at 2 distinct points, so that the circles will need to be a little bit bigger, so that they intersect in 2 distinct points. So let's go ahead and get started. We'll draw our segment, length of 4 centimeters. And point A is going to be the center of one of the circles, and point B will be the center of the other circle. Then I want to take my compass, and I want to mark the radius. Remember, if it's exactly halfway, then we'll have circles that intersect in 1 point. If it's less than halfway, they will not intersect. So it needs to be more than halfway. So that is going to be the length of my radius. I'm going to go ahead and rotate my paper to draw my circle. And that didn't come out exactly right. And that's okay. I moved my compass, so it's not the right length now, so I'm going to remeasure it. There we go. Then I'm going to move the tip to point A, and I'm going to draw the second circle. And rotate my paper around. There's my first intersection. There's my second intersection. There we go. Now, it says label the 2 points where the two circles intersect, C and D. So here's one of the intersections, that is point C. Here's the other intersection, point D. Go a little closer here. Join A and C with a segment. Okay, A and C right here, and we'll want to use a straight edge. And notice that that is the radius of that circle. Join B and C. And notice that that is the radius of this second circle. Join A and D. So A is the center of the circle, and D is the point on the circle, so that is a radius of this circle. So AC is a radius of the circle, and AD is a radius of the circle as well. And that means that those two segments are the same length. Then B and D. Notice that B is the center of the circle and D is a point on the circle, so that BD is a radius of this circle, and BC is a radius of this circle as well. Since they are both radii of the same circle, they have the same length. So here, notice that these segments are the same length, and you have a triangle with two segments of the same length. Do you recall that that is called an isosceles triangle? And then this has the same length for both triangles. These two are the same length, so this triangle is an isosceles triangle as well. So it says, what kind of triangles are they? They are isosceles. I-S-O-S-C-E-L-E-S, isosceles triangles. And we explained that they are isosceles because they have two segments of the same length, because they are both radii of circles that are the same size. Determine all possible measurements in the following triangle and use your tools to create a copy of it. Alright, so one of the things that I notice here that this is a triangle and it has three sides. I know that this is a 90-degree angle because of the mark here. I know that this length needs to be the same length on the new triangle, and I know that this length needs to be the same length on the new triangle. Let's move this up a bit. And the compass is going to help me measure out this length and then mark a new length. Alright, the first thing I want to do, I want it to be in the same orientation as this triangle, so I'm going to go ahead and I'm going to make this 90-degree angle down here in this area. I'm just going to start by making a segment, and then I want to mark off how long that segment should be. So from here, I'm going to put my pencil tip on the vertex. I'm going to measure the length of this segment. It's a little hard to do here. I'm going to alright, so there I've got it marked. Now what I want to do is I want to move this tip to this end, and then I want to mark off the arc. That shows that this is the same length. Then right here is the end. Now I want to show a 90-degree angle, so I'm going to use my protractor, mark here, line that up with the mark on the protractor, level off your protractor with the segment you've just drawn so that this shows to 0, and then I want to show a 90-degree angle, and 90 degrees will be right here. Then I'm going to go ahead and I'm going to draw that segment, and I don't know yet how long it's supposed to be. Just going to do it lightly there, but I do know that this is 90 degrees. Now I want to measure this arc, or this segment, and then mark it on this segment using my compass. So I'm going to put my tip on the end and my pencil tip on the other end, adjust this to the right length, and then I'm going to move this tip to this point, and I'm going to mark off the length of that segment so that this distance is the same as this distance. Finally, I'm going to use my straight edge to make the third side of the triangle. And there I've made a copy of my triangle using my tools. In this lesson, you've learned that the compass is a tool that can be used for three things. It can be used, the compass can be used to construct circles, it can be used to measure and mark segments of equal length, measure and mark segments of equal length. You can confirm the radius of a circle to the circle itself. Remains constant. No matter where you are on the circle. And what that means is that when you measure out the radius on your circle and you rotate it around, such as this one, let's say here you've measured out your radius and you rotate it around. As you're rotating it around, this length is your radius. 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 So the radius remains constant. The radius remains constant no matter where you are on the circle. And that concludes Lesson 6.